Okay, so let's continue to solve this example. Is the example 2.24, and on the last video we were simplifying this matrix. So this matrix is the matrix that we evaluate using the octave and is a product of these other matrices, which is describing a transformation. So each of these matrix, as we already discussed it represents the sequence of the four motions, which is the motions from the procedure that we need to do to accomplish a transformation, and is a method for DH representation, which is a method that is a standard method to use to represent any type of robot arm with any number of joints and links. Okay, and on the last video we were simplifying this matrix, and what happens is that I speed up the explanation of how the book is simplifying this matrix. So actually the book doesn't let explicit how was done, but it's very easy. It's just this property of the trigonometry, and I call this identity, but actually is a property. So let me explain again and we can finish this example. So again, right here, as you can see on these columns, we got a product between two components of cosine and a subtraction of two components of the product between two components of sine. And this is something that we can relate to this property that we can from trigonometry. So we can, if we recall this property, it says that a sum of arcs or angles A and B, or a subtraction between these arcs or angles. So cosine of A minus B is equal to cosine of A times cosine of B plus sine of A times sine of B. And if you can notice, this property is very similar to what is being returned right here on these elements of this matrix. So we got a product of two cosine components and a product of two sine components. So if we substitute on this property, we can see the similarity. So a cosine of these two angles, θ1 and θ2. So again, there are two angles, θ1 right here and θ2. So it's about these two angles. So they are equal to cosine index 1 from the angle θ1 and cosine index 2 from the angle θ2 minus sine index 1 and sine times sine index 2 from these angles, theta 1 and theta 2. And this relation, which is equal to a cosine of the sum of these two angles, we are calling as C1 and 2, not C12, C1 and 2 from the angles, the data angles 1 and 2. And yeah, we still do not wrote the matrix, so this is something that we will do right now. Okay, so we got this element which corresponded to this element, okay, and also we got again a property from trigonometry, which is now a sum of arcs or angles, but with the function sign. Right here we are using the function sign to sum up these angles, and is equal. Okay, so again, using this example, this expression as example, if we are doing a sum of using the sine function to sum up these arcs or angles, and this can be also wrote as sine of x plus x. So this is equal to 2 sine of x times cosine of x. And actually, again, this is also can be wrote as sine of cosine plus sine of cosine. So 2 sine x times cosine of x. And now in this property we can see a similarity with this element. So right here we'll call this as sine 1 and 2 because of the angles, and right here is minus. And also this element, it repeats right here, but with a opposite sign. And again, this element is the same as this element. So we got these two elements, to different ways to see this matrix. We are just simplifying using this trigonometric properties, not identities, properties. And right here, just give a briefly explanation so you can see better how this is done. Again, if we are summing up two arcs or angles, so cosine of 2x is the same as cosine of x plus x, and right here we just switch the sides of these elements on the equation. Okay, and cosine square. And okay, I did this because I wanted to show to you that again right here is the same property as we are using right here above, but we extend to see better that now we got this property, and this is sorry, now we got this identity. Now this is a trigonometric identity, and or not, I think the trigonometric identity, for example, if this was a sum signal, a plus signal, so then this identity will be 1, but right here is minus. Okay, never mind. So cosine square, sine square, because we are multiplying two cosine components, and right here I'm multiplying two sine components. Right here, two cosine components, and right here two sine components. And right here is difference for the sine function. If we are summing up two arcs or angles using the sine function, we will obtain this expression. Okay, and actually I do this because I thought that we will obtain right here the identity, but the identity I think is, yeah, I think is cosine square plus sine square, which is equal 1. But right here is cosine square of x minus sine square of x. And this is not the identity. Okay, so now we can go and rewrite this matrix by using these simplified elements. And doing this, we finished this example, and on the next video we will solve another example. Okay, so as you can see right here, we will substitute for cosine 1, 2, and right here sine 1, 2. Okay, and again, if you can see, if you can notice the similarity of this element with these properties. So for example, right here is the same, right? So again, cosine 1, 2, and again right here this trigonometric property is the same. It tells to us that this element is equal. So this is minus sine 1, 2, and right here 2 cosine 1, 2, and right here is the same. Sine 1, 2. And that's it. The simplified matrix. Which represents the total transformation in relation of the frame of the hand in relation to the frame 0. So transformation of the H frame in relation to the frame 0.